Hello, I'm Yasir. Today, I will try to apply the Matlab solver, the another Matlab solver, which is called bvp4c, to solve initial value problem. Normally, bvp4c is used for boundary value problem. Uh, one or more than one equations can be solved by with boundary condition can be solved with the bvp4c. But today, I will try to apply bvp4c for initial value problem. So in initial value problem, so I'm using the SIR model. So it's a non-linear model. First two equations are non-linear. I will try to apply BP4C for this model. For applying this method, so I start coding and I will write CLC to clear screen and then clear all memory clear and then it's open. So I will, because the SIR model as your model contain two parameters, beta and gamma. So I will specify the values of beta and gamma. So beta suppose that is 0.1 and gamma is also 0.1. It can be the can have some other value 0.1. Now I will start the function which has the independent variable t and dependent variable you can say it's a u. So the first one is the right hand side. The right hand side of the right equation, the right hand side of ds by dt. On left side, only first derivative is written on the right side. So when the equation will have this kind of form, the derivative is the first derivative. The first derivative will be written on the left side, and the remaining terms are on the right side. So I will use the right hand side. If the equation is written in this form, the right hand side would be minus beta is. So I will be represented as u2 and s will be represented as u1. There is no r on the right hand side. So if there would be r on the right side, then the equation then the it will be represented with the u3. So there is no r on the right side, so there will be no u3. So only because s and I, so all the three equations contain SIR, s and I dependent variables. So these will be represented with u1 and u2. So it's minus beta is minus beta beta I is represented as U2 and S is represented with U1. And then the semicolon for second equation. For second equation, I will write, so beta is the second equation says di by dt is equal to beta is minus gamma I. Beta is minus gamma I. Beta I represented with U2 and S is represented with U1 minus gamma into U2. And now the right hand side, it's gamma I. So for gamma I, so it's a gamma, and I will represent it with U2. So that's a function containing the right hand side of the three differential equations. Now I will use the initial condition because BBB4C is used for boundary value problem. So I will give two variable. One is U0, other one is U1. The U1 for left hand side of the domain of the boundary and U1 will be used for the right hand point. The U0 is do not represent the left hand point, the very most left end point or the first point, the first grid point. And U1 is represented for so that will give the value for the very most right hand point. So the initial condition suppose that I use because it's an initial value problem, so only U0 will be used, U1 will not be used. So only U0 will be used because all the values are given on the first grid point. So U0 1 means that S1 mean S, 2 mean I, and 3 mean R. So not U naught mean it's a left endpoint. So U1 will be the right endpoint. So U naught is left endpoint minus, I suppose that I first value is 5, and then U naught 2 means it's the first condition for S, second condition for I. So that's why so it should be a U naught, not U1. So suppose that is 5, and then U naught 3, the recovered one. It's supposed that I mentioned with minus 4. And I close the bracket. So that's for boundary condition. The first function for the first function for differential equation, and the second one for the initial conditions. Now I will write the initial guess, you can say, and the independent variable. The initial guess BBP. So this BBP I and IT will be fixed. So this left hand side can be changed. So I will start with the independent variable. Independent variable start with 0 and it end at 10, and the number of points I can choose for initial guess, it can be 10. And then the initial condition I will use, not initial condition, just initial guess. So the initial guess for three equation is just 0, 0, 0. It can be any other number. The solution, if it have if a system has more than one solution, then changing the initial guess will give uh, uh, more than one solution. So one initial guess can so using one initial guess, some other solution can be found. No, sorry. So two different guesses can give two different solutions. So no. What I will do, I will use bvp4c now. For bvp4c, I will use bvp4c, and then the differential equation function, and then the boundary condition function, and then the initial condition function. I. So now I will get the solution. The solution will be t. So I will divide 0 to 10 into 50 grid points, and then for U, I would have that I have a dependent variable U, and so DEVAL, and then solution will be evaluated at the point T, and then so the function, suppose that if I plot, so this one, so I run this, so the susceptible will be shown on the graph. So plot LT. Light on, light on, light on. So this is the solution. These are susceptibles. Similarly, I can find the solution for infected one. So for infected, if I run this, for infected, it would have this kind of one. And for the recovered, I would have this kind of. So I can compare the solution of OD45 and the bvp4c. So I applied the bvp4c. Now if I applied the OD45, so what will happen if I apply the OD45? So OD45, Papa. So for OD45, it's a function and then it's a domain boundary. Let's say it's a domain. It's a 0 to 10 and then with 60 points and then the initial condition. The initial condition is 5, 5 and 4. So if I plot in this plot, if I use the OD45 solution as well. So what will happen? Oh, so one is recovered V3 double dot. So that's a recovered, that's susceptible. So these should be the susceptible. So no, both are susceptible. So it's showing one curve, but it's actually a two curves. The overlapping case, the overlapping. So now I find the absolute difference of these two. How much the absolute difference is? So absolute difference of bvp4c and the OT45 is, I think it's so this is the solution. Error. You can say the difference between it's absolute difference. It's absolute difference between the bvp4c solution and OD45. So it says that it's multiple by 10 to the power of -4. So it's a small difference between the two solutions. So that's it. So I today I solve the SIR model, the uh, initial value problem, differential equation with initial condition are solved with the Matlab solver bvp4c. bvp4c normally solve the boundary value problem. In my upcoming video, I will try to solve some boundary value problem with the bvp4c. But for today, I solved the SIR model, the initial value problem with the bvp4c. And I also compared the two solutions. The solution obtained by BB4C and the solution obtained by OD45 solver. The OD45 is the initial is used for initial value problem. So BB4C is used for boundary value problem. So I end this video. Okay. Bye. Allah Hafiz.